So I'm going to share progress with the Nixie relay logic clock that I'm working on. I've done a lot of work on sort of the housekeeping functions that are going to be on each PCB. There's going to be four boards, seconds, minutes, and hours, and a control board. And so what I have here is the design for some of the control logic that goes on each of the counter boards. For self-testing, I want to have an oscillator on board, so I have a 5-5 timer. It generates a clock pulse that comes out. I also have a push button that you can press, and that generates clock pulses. And then the processor is going to be the main way you clock this thing. It comes in here, and it can drive the phase generator, which generates the two opposite phases, which actually run the counters. You can see that operating there. And then there's a reset relay, which removes both phases, and that clears out whatever bit is floating around the counter. And there's also a preset relay, which is this, which is the thing that first injects a bit into each counter, and it can be set and reset via the processor or a button. So I turned this schematic into a board design, and I added it to the prototype that I'm assembling. This is just a test of the assembly process, and working with the wire wrap and the soldering. And you can see, actually, this is the one that shows it. You can see, you have the timer circuit and the three relays as shown, and then on the back, I in Illustrator flipped it over. And so you can see the traces, and so you can see how this power trace up here, it's the power trace here, and this ground trace there is the ground trace here, and so forth. So I built this. I got good at sort of improving my technique on making the solder bridges. I did the clock wiring for the relays in wire wrap. I think I'm going to do that in actual wires on the real thing. You have to solder on these posts, which requires some fixturing, and then you do the wire wrap, and you might as well by that time just put a wire there instead of the post to later wire wrap it. Anyway, so I'll show you this in operation. It just requires power, and when you turn on the power, here it's running, it's been preset. I can go to manual step modes. I can load in a bit, I can manually step, I can clear it, and then I can load in another bit. And you can tell it's in preset mode because this relay is on, but the previous one isn't. It's being driven by the preset relay. But then once I clock it, the bits travel through. So the idea, and then I also actually have processor lines. These are connectors, 5 volts over here, so I can attach this wire to 5 volts, and that would clear the system. This wire activates the preset, and then I can then clock it with this wire, and you can see it. You can see it clocking. So this is a good test of just the layout and the size, and I'm still waiting to get the chassis to understand when I have it. This is what the real PCB size would be, to understand where the connections need to go in relationship to the front panel and the board orientation. But once I do that, I'll be able to actually start building real things. One of the issues that came up was when I first built this, I couldn't get the clocks to go, and I was wondering what was wrong, and so I swapped out a relay with another one, and it still didn't work, and I did a lot of debugging, and I was sort of curious, do I have bad relays? And so I built this little tester board, and if I hook it up, this is designed, you can take a relay and you can plug it in, and you can see the normally closed contacts, and you can just sort of check a relay to see if it's operational. And it turns out my relays weren't bad, but I had forgotten that when I initially started the project, these are 5-volt relays, and I bought one pack of 12-volt relays just for whatever reason, just to compare them, see if they were better or whatever. And I inadvertently added that to my box full of relays I was just grabbing. So I happened to grab two 12-volt relays, and it says what the voltage is in hard to read writing, and so it took me half an hour to figure that out, and I felt kind of stupid. Actually, I thought the relay was bad, and I measured the coil resistance, and it was higher than expected, which means 12-volt relay, duh. Once I did that, everything was okay. So I did a lot of work. So actually, I'm happy with this design, and again, I'm going to start making the real thing once I figure out the layout. I then moved on to, actually, I'm going to show you talk about how the counter works. And actually, I'm glad that I've been drawing nice diagrams on the circuits. So I described before how here are the two relays that are in each stage, and it passes the bit from stage to stage. Here's a more detailed look at would be the seconds and the minute counter. And so each of these stages, 0 through 9 and 0 through 5 for the minutes and the seconds counter, actually inside it's the two relays, the yellow and the green relays. That's the green, that's the yellow relay, and these come in pairs. But for simplicity's sake, I just show each stage. Each stage again is a pair, and the relays are just hooked up in sequence and they wrap around. And what's shown here is that there's an output which comes from the green stage, and that drives a digit. So this in stage 0, it drives the 0 of the ones counter, and then in stage 4 it drives the 4 in the ones counter, and it wraps around. The bit that comes out of the 9s in the singles, in the ones, it gets used to clock the 10s digit, and that's 0 through 5 stages, and that loops around, and I get an output that corresponds to what digit you want lit up in the Nixie tube as it goes. So this is the Nixie tube again, and then the circuit that drives Nixie tube, I have a boost converter that turns 5 volts into 170, and that gets used to power multiple tubes, and it goes through a current limiting resistor because it only wants 3 milliamps or so, and that goes to the anode, which is this grid. You can kind of see it in the reflection. It's just a grid that's over there. And each of the digits plus decimal point, it's a piece of metal, and it's attached, and that forms a cathode. And you can kind of see here, these pink things are insulating washers, and between each one is a sheet of metal which forms the digit. And if you look really closely, you can see the wires that come off of each digit that go to the actual pins. And so to light up a Nixie tube, you need to complete the circuit, which means grounding the cathodes, and that's accomplished by these high voltage transistors, which are driven by the digits, or the signals that come out from each stage to drive the digits. So if I want to light up a 0, if you put this 0 signal at 5 volts, it puts some current into the transistor. The transistor is like a switch, so when there's current present coming into the base, it allows a larger current, usually a factor of 100 typically, to flow from the collector, which is here, to the emitter, which is ground. So this just acts as a simple switch, and you have multiple of these. There's also going to be a colon and an AM/PM indication, and that's a different kind of device, and it has a different current limiting resistor, and that's shown here. And I have this put into a piece of plastic. I'm still trying to work out. I'm probably going to paint this black, and then this is going to stick through the chassis. These go in sockets, and I need to figure out the spacing for the digits, but there'll be colons, and then there'll be an AM/PM someplace. So I need to work out that spacing once I get the chassis and I figure out how things are connected. This clock is going to be both a 12 and a 24-hour time format, and so I was working on just the complexity there. And 24 hours is simple. It goes from 00 to 23, and then it loops back around. 12 hours kind of weird. It goes from 2, in one stage it goes from 2 to 1 to 2 to 3, back down to 1 to 2 to 1 to 2. Has a weird cadence to it, along with the AM/PM, and then the 1 is set at some irregular interval as well. So I figured out how do you make one of these counters work, and so I started first. Well, let's do a 12-hour And the easiest way to do a 12 hours is to count actually in base 12. And so I have 12 stages, and then it carries to a AM/PM stage, and the AM/PM stage would just light either the AM or the PM, Nixie Tube device. And then to light the digits, instead of having tens and ones counter like I have before, you can just use that one signal, and if it's at stage 0, which is 12, I'd drive the 1 signal into the tens and a 2 into the ones, and then when it's 1, I would not drive anything into the tens and drive a 1 into the ones counter. And you have to have diodes here because if I'm driving a 1 here, you don't want it to drive the 1 backwards and make a bigger circuit. So these just block the current from coming back in and actually turning on more things than you want. That's a simple 12-hour counter system. I then said, well, I can do a 24-hour counter just the same, using the same technique, 24 stages. Takes a lot of relays, 51 relays and 48 diodes. So that's a lot of stuff, and it doesn't allow me to switch between 12 and 24-hour time. I worked on another scheme where, I have a 24-hour, 24-stage counter like I did up here, but then when I'm in 12-hour mode, it just sort of cuts it short, and I still have to have a counter for AM and PM, and that design requires 58 relays, so only 7 more than the 24-hour base 24 counter, and 51 diodes, which again, not going to fit on this PCB, and it's fairly complex. So I worked on some other ways of doing this, and actually have a solution which I'll show next time when I show the actual full design. I don't want to demonstrate that now because I just have the one Nixie tube, and it's a little bit better if I had actually 2 of them to show. Nixie tubes are coming from Russia. They arrived in the United States 3 weeks ago, and they're stuck someplace in Connecticut. I got this one, it's more expensive, from a place in the United States, and I ordered 2 more earlier this week, so I'll have them tomorrow. Also be able to demonstrate what the 12-hour, 24-hour solution is like. So anyway, lots of progress. Next stage is going to be actually starting to assemble the seconds and the minutes counters on PCBs, and the other thing I'm working on is having the Arduino with the GPS and real-time clock. Not necessarily associated with this stuff right now, just working on the software to grab the time off a GPS, display it on an LCD display, store it in the real-time clock, and be able to take it out of the real-time clock and after it powers up. So that's some software work which I'm going to get into also. So lots of progress, lots of fun. I'm glad I'm taking good notes in my notebook, because 10 years from now, or I don't know, 10 days from now, a lot of these details might get lost. So it's just good to have nice record doing this stuff. Anyway, that's all I have to report for now. I'll probably have an update on the weekend once I get the Nixie Tube. All right, thanks for watching. Bye.